Hi guys, this is lesson 110, Operations with Scientific Notation. To start off, let's try these 5 warm-up problems. Pause your video and come back and check your answer. Okay, our first one, simplify using only positive exponents. So if we look at our very first problem, we see this is the power rule. Okay, we have something raised to a power, raised to another power. And that power rule tells us we need to multiply our exponents. So in this case, our base is still going to be 15, but 8 times negative 3 gives me negative 24. So the only problem with that is we're not allowed to have negative exponents. It says use positive exponents, okay? So what we're going to do is we are going to take the reciprocal of this number. So if I put it over 1, I'm going to flip it upside down. And when I do that, I get 1 over 15 to the 24th power. And that is allowed because that has a positive exponent. Okay, remember when you flip it, your exponent becomes positive. Okay, for this one here, we have x to the 6th power times x to the 5th power. This is the product rule. So since our bases are both x, my answer will have an x in its base. And the product rule tells us we have to add our exponents. So 6 plus 5 gives me 11. We have a positive exponent, so we're good to go. Okay. For the third one, this is the quotient rule. We are dividing 9 to the 15th power divided by 9 to the negative 10th power. So both of these have a 9 as my base. My answer will also have a 9. And I need to subtract. Be very careful because you need to subtract 15 minus negative 10. What happens when we have a minus side by side? That just doesn't look right. So when you have a minus, you have to make them both positive. So 15 plus 10 actually gives us 25. So this would be 9 to the 25th power. Okay, again, it's a positive exponent and that's allowed. Okay, for the next one, it says write each number in scientific notation. So this is what we talked about in our last lesson. So I have to put a decimal point in here somewhere that's going to make this number between 0 and 10. So not less than 0, not greater than 10. So if I put it in here, the best place would be here after the 9. Okay, so I'm going to write this number until I get to the 8. So I have 9.008 times 10 to what power? So to determine what power it is, I need to take this decimal point and move it to the end and see how many spaces that is. There's 1, 2, 3, 4, 5, 6 spaces. So it's going to be 10 to the 6th power. Okay, for number 5, same thing. Where can I put my decimal point to make this between 0 and 10? Well, I can put it right here at 8.7. So that becomes my coefficient in the front. Times 10 to what power? Well, how many spaces is it going to take to get from my new point to my old point? So I have 1, 2, 3. Whoops. Let's try that again because my squiggles got a little bit big there. All right, 1, 2, 3, 4, 5 spaces. And because this is a small number, it has to be a negative 5. Okay, anything that is less than 1, if my original number is less than 1, it's going to be a negative exponent. If my original number is bigger than 1, it's going to be a positive exponent. All right, so this is just some more review, okay? Write the numbers in scientific notation. Here's the new part that we did not talk about. Okay, if you're looking at these, all 4 of these are already written in scientific notation because I see the times 10 to a power. The problem is, if you notice, 71 is not between 0 and 10. So I have to fix it. So here are the rules down the bottom. If you have to move the decimal to the left, you're going to add a number to the exponent. If you have to move your decimal point to the right, you're going to subtract a number from the exponent. So for example, for this one here, right now, 71 has a decimal point, an imaginary decimal point at the end. So we kind of put it in there. Okay, all whole numbers have a decimal point at the end. In order to make this number between 0 and 10, I have to move it left 1. I'm going to have to move it so that way it becomes 7.1. Now, because I had to move it left, if you look down here, when you have to move the number to the left, you need to add a number to the exponent. So instead of being 3, this is going to become a 4. Now, this is in proper scientific notation. Okay, for number 2. So in order to get 0.63, that is less than 0, or sorry, less than 1. So I want to make it between 1 and 10. So I need to move this over 1 to the right to make it 6.3. Okay, I want at least one real digit in front of my decimal point. Now, because I had to move to the right, it tells me down here that I need to subtract 1 from the exponent. So the 5 is going to become a 4. And now we are in proper scientific notation. Okay, over here, this is a whole number 33, has an imaginary decimal point at the end. So to make it into the proper form, I have to move it over 1 to the left to make it 3.3. And it says that if I move left, I have to add to the exponent. So think about this. This is -3. -3 plus 1. If I'm thinking about a number line, okay, here's -3, -2, -1, and 0. If I'm adding 1, I have to move to the right. So it's actually going to become -2. Subtracting, you would move to the left. Okay, and then our last one here, I would move it 1 space to the left to make it 2.45 times 10. And since we moved left, we're going to move the exponent. We're going to add 1 to it. So instead of being 7, it's going to become 8. Okay, so you may want to jot that little rule down. Moving the decimal left, you add to the exponent. Moving it to the right, you subtract from the exponent. All right, for today's lesson, you are definitely going to need either a piece of paper, a calculator, and a pencil, or if you happen to have a dry erase board or a whiteboard, that would be great too. We're going to be practicing a whole bunch of these, and I want to make sure that you guys are able to write them down. These are not things that you can always solve in your head, so I strongly encourage using a calculator, paper, or a whiteboard. Okay. So today we're going to be talking about multiplying and dividing numbers that are in scientific notation. So it says multiplying with scientific notation. To solve, you multiply the 2 leading numbers and add your exponents. So in this case, our leading numbers are the numbers that are in the front. So we have 3 and we have 9 because we're trying to multiply this scientific notation times this one. So all I have to do is multiply 3 times 9. Well, 3 times 9 is 27. Okay, now I have to add my exponent. So we multiplied the leading terms, now we're adding the exponents because this is the exponent rule. When you're multiplying 2 exponents, just like our our product rule, you have to add your exponents. So we're going to do -7 plus 3. So -7 plus 3 means we're going to move 3 spaces to the right on the number line. So we're going to go -6, -5, finally to -4. All right, now what do you notice about our answer? Yeah, we can't keep it like this because 27 is not between 0 and 10. So we have to fix it. So here's my imaginary decimal point. I have to move it 1 space to the left. So it's going to become 2.7 times 10. And then remember our rule from before, I'll go back. Since we moved to the left, we're going to add our exponent. So our exponent was -4. If I add 1 to -4, it's now -3. Okay, just remember those negatives are opposite of what you think it is. All right, so I would like you guys to try this one right here. Go ahead and pause your video and try this example. All right, so let's see. When you do 2.3 times 5, you get 11.5. Times 10, if you add 6 and 3 together, we get 9. Okay, again, I noticed that 11.5 is too big. It has to be a single digit in front, not 2 digits. So I want to take my pen and I want to slide 1 space to the left. So this becomes 1.15 times 10 to the, just like we did before, when you move left, you have to add 1 to it. So instead of being 9, it's going to become 10. Okay? Sometimes you have to fix it, sometimes you don't. It all depends on what your answer is. Okay, so here's a quick check. Go ahead and pause your video. I would like you to try A and B, and then we will talk about C together. All right, so if you multiplied our leading values 4 and 6, you have gotten 24. Now for our exponents, we keep the 10s, but we have to add 4 and 6 together. 4 plus 6 is 10. All right, I know I can't keep my answer like this because 24 is too big. So I put my imaginary decimal point in. I have to slide one space to the left to make it 2.4 times 10 to the, if I add 1 to my exponent, it'll become 11. All right, let's look at B. If you take 7.1 times 8, you get 56.8 times 10 to what power? What is negative 8 plus 4? Well, negative 8 plus 4 is negative 4. Okay, once again, I notice 56.8 is too big. I need to move it so it's smaller. So I'm going to move it 1 to the left. So it becomes 5.68 times 10. And then if I add 1 to negative 4, it becomes negative 3. Okay, if you are unsure with the negatives, draw a number line. Move right when you add, move left when you subtract. Okay, this bottom one is a real life example of when you might see multiplying our scientific notations. So a hydrogen atom has a mass of 1.67 times 10 to the negative 27 kilograms. So I could tell right away, hydrogen atoms weigh very, very little. Okay, that's a very small number because it's a negative exponent. What is the mass of 6.10 to the, I can't talk today. 6 times 10 to the third power hydrogen atoms. Okay, so basically we want to take this and multiply it by 6 times 10 to the third and see what we get. Okay, so I'm going to multiply my leading numbers. So 1.67 times 6. 1.67 times 6 gives me 10.02. And then I'm going to add my exponents. So I need to add negative 27 plus 3. Well, negative 27 plus 3 gives me negative 24. You guessed it, we have to move our decimal point. Although this is 10, it's a little bit over 10. We want that first number to be a single digit in front of the decimal point. Okay, we don't want a double digit in front of it. So I'm going to move my decimal point one space to the left and make this 1.002 times 10. And then if I add 1 to negative 24, I get negative 23. So that is how much 6 times 10 to the third hydrogen atoms would weigh. All right, so now we come to dividing. So for dividing, you have to divide the leading digits, so the ones that are in the front, and then you subtract the exponents. This is just like the quotient rule that we talked about. So in this example here, we have to divide 50 divided by 5. Well, 50 divided by 5 is 10. And then we have to subtract these exponents. So I'm still going to have the times 10 part, but negative 8 minus negative 4. Be very careful. Negative 8 minus negative 4. I see I have a minus minus, so I'm going to make them both pluses. What's negative 8 plus 4? Yes, it's negative 4. Now, just like before, our number has to be a single digit. So we have to take our imaginary decimal point that's at the end, move it one space to the left. So this actually becomes 1, or you can say 1.0, times 10 to the, what's negative 4 plus 1? You get the negative third power. Okay, so again, you divide the first numbers, you keep your base 10, but to find the exponent, you have to subtract using the quotient rule. Go ahead and see if you can try the two that are here. Go ahead and pause your video. All right, so for this one here, we're going to divide 4.5 and 1.5. And if we do that, we get 3. And then we have our times 10. 5 minus 2 gives me 3. This is okay because if you notice, our first number is between 0 and 10. Okay, so we are allowed to keep that. Okay, now over here, 6 divided by 8. 6 divided by 8 is going to give me a very small number. It's going to give me something less than 1. In fact, it gives me 0.75. All right, times 10. And then if I do -3 minus -6, let me write it out. -3 minus -6. There's that double negatives again, so we're going to make them pluses. -3 plus 6 is going to give me 3. Okay, now just like before, we have to change our, oops. Yes, I was looking at the right one. Sorry, I thought I was going crazy looking at the wrong one. 0.75 is too small. It is less than 1. And we want it to be a single digit in front of the decimal point. So I'm going to take my decimal point. This time I'm moving it 1 to the right. So if I move it right, I'm not going to add 1 to the exponent. I need to take 1 away. So this correct answer is 0.75. Sorry, not 0.75 because I forgot to move the decimal point. 7.5 times 10 to the second power. I had to take 1 away. All right, so here's a quick check. Before we move on to a showdown, to see how you guys did, I want to make sure that you're understanding how to do these. So go ahead and pause your video, try these two, and then we're going to have a showdown. Okay, so let's look at this. 5.4 divided by 1.8 gives us 3. And our exponent's -5 minus -2. -5 minus -2. If I change my negatives to positives, I have -5 plus 2, which becomes -3. Is that answer allowed? Yes, it is. The main thing is that this number has to be a single digit or in front of the decimal point. All right, our next one, okay, I have 1.2 divided by 1.6. That gives me 0.75 again. And then 4 minus -3. 4 minus -3, I have to add. So really it's to the 7th power. But this one we do have to change because 0.75 is too small. So I have to move it 1 space to the right to make it 7.5 times 10. And do you remember what we did in the last page? Yes, we had to subtract 1 from the exponent instead of adding 1. So it's going to become to the 6th power. All right. So now we're going to do a showdown. So the way this is going to work is I'm going to show you a problem. You're going to pause your video. You're going to solve it on your whiteboard or on your paper, and then you're going to unpause it to reveal the answer. For these ones, I am just going to show you the final answer. If you have questions about any of these, please send me a message. And then once we get done, I will show you your exit ticket. So our first problem is a multiplication problem. So 1.08 times 10 to the -3rd power times 9.3 times 10 to the -3rd power. Go ahead and pause your video. All right, what did you get? You should have had 1 times 10 to the -5th power. All right, for our second one, here is another one. Whoops, move up a little bit. Go ahead and pause your video. All right, for this one, we should have gotten 1.62 times 10 to the -4th power. Ready for number 3? All right, another multiplication. Go ahead and pause your video. So for this one, we should have gotten 9.28 times 10 to the -11th power. Let's try a few more. So for this one, number 4. Number 4, our final answer should have been 3.4104 times 10 to the 8th power. All right, go ahead and pause your video for number 5. So this was a division problem. So when you divide it out, you should have gotten 1.3 times 10 to the 8th power. All right, one more on this slide. It's another division problem. Go ahead and pause your video. Okay, for this one, our final answer is 6.4 times 10 to the negative 6th power. All right, I do have two more for you just to practice. If you feel that you need to do them, go ahead. If you feel like you're ready to move on to the exit ticket, you can do that as well. All right, here's number 7. Go ahead and pause your video. Okay, for this one, our final answer should have been 3.5 times 10 to the 12th power. And finally, number 8. All right, our final answer should have been 4 times 10 to the 3rd power. Again, if you have any questions about any of these, please send me a message. Just make sure you let me know which problem number it was, and then we can talk about it. Okay, your exit ticket is on Schoology. It is these two problems here. So if you would like to solve them on paper before you go into Schoology to put your final answer in, you can. Remember to use the caret button. The caret button looks like this. Looks like the roof of a house when you're trying to put in your exponents. Okay, if you have any questions, I'm available in our virtual classroom or by email or messaging on Schoology.